Hi, everybody. My name is Ethan. It is week 10 of the summer quarter at Drexel. This is Drexel AI's 10th meeting of the summer term. It is August 24th, and I'd like to go through some of the changes I made in the past couple days to the paper, and we can talk about what we're going to plan on doing next quarter, the quarters to come. So I talked about these two kind of figures I put together. While I'm doing this, I'm just gonna exit out of some things. And what I did is I took the liberty of adding it to the paper. So we have the just signal right here in the data section, dataset section, just to highlight this is kind of how we're splitting it up. And then here we have, half a page dedicated toward the algorithm, which is about the size that I wanted it to. And then a majority of it is explained in the caption here. And then on the results section, these are our results. So a couple of things, right? I'd like to add a bit more about the algorithm in the algorithm section right here. I kind of feel it's backwards to have the caption explain most of the algorithm, whereas the algorithm section of the paper doesn't really have that. So that's something I have to add. So if we go to algorithm, I wonder if it'll be easy to find the figure right here. Yeah, I'm gonna just add in red. And this whole coloring thing is something I always use to understand who does what and when things should be added. I just color code. It makes things a lot easier. And then sprinkled in here are some other red sections that I'd like to add still. For instance, we still need to explain the LSTM model. And then we want to read over the ISTA model explanation that either Savek or Ansh worked on. Can't remember who. And then there was one other reference I wanted to include that talked about time series forecasting with sparse coding, or at least sparse coding a time series data. Yeah, so multi-step ahead time series forecasting via sparse coding dictionary-based techniques. So this kind of falls in line with what we've been doing. So I'd like, I'd like to include that. The time series, it looks like they take the time series, they smooth it, and then they find a sparse representation of some vectors, and they can use the extracted targets and dot product, something like that. So they're using the dictionary to forecast y hat. What we're doing is we're trying to optimize the weights of an LSTM model based off of a reconstruction error. So we're like evaluating this, and if the reconstruction error is low, then that means that the dictionary is well suited to that the weights are well suited to predict the future. It's kind of like the synopsis, and I'd like to contrast that in the background section, and that's something that I can do over the weekend. I'll probably dedicate my Sunday to this. Now for the results, they're not terrible. I would like to run them again with some different parameters changed, because we're effectively trying to compare the first and second column together and the second and third column together. We want the optimized weights, of course, for R2 to be higher in magnitude. In some cases it is, but whether or not that's significant, is another story, right? And then we want the RMSE to be lower. In some case it is, some case it isn't. Whether or not it's significant is, of course, the question here. And I'd also like to visualize the predictor, like what's being predicted, right? So I'd like to take the weights of the best. I'd like to take the weights from the 10th generation and compare it to the weights of the first generation for a handful of these partitions. But I really don't think that these results are indicating that the algorithm is bad. I think that it may need some tweaks in terms of hyperparameters because, right, the LSTM model we're working with is relatively simple. If I go into algorithm.py, which is what's on our GitHub, if I go to predict forecast, you can see that when we build the model from the build model function, it's relatively simple. It's not complex at all. And I didn't want to add a super complex model to begin with. And we're using early stopping. So what that means is that the model will stop training and stop back propagation during the training process once it realizes that the weights haven't converged at all. What might be interesting is if we get rid of early stopping and just say you can run for at most 2 or 3 epochs, something like less than a handful, and then see if this algorithm can actually optimize the weights itself without relying on backprop, which would be interesting. But backpropagation has been known to find weights that are most ideal for a neural network. So I don't imagine that this would do better than backpropagation. I kind of imagine that it would coincide with it to optimize it to find weights that are best. But regardless, I'm not too terribly disappointed with how the paper turned out. We kind of had a shot in the dark with the idea. I actually named it EvoSTS for it's evolutionary sparse time series. It's kind of what I named it. We can reject that idea. You might even want to make it more obvious in the title, right? Evolutionary sparse time.
Spelled series wrong.
You didn't give me a chance to correct myself, did you? EvoSTS forecasting, something like that. I don't know. I kept referring it to as the algorithm throughout the paper, and I didn't like that. Makes me sound like I'm like Mark Zuckerberg or something. The algorithm. Yeah. Yeah. But the question is whether we feel comfortable with publishing it. The question is whether we want to publish it as is, or wait until we do a greater hyperparameter search. I'm sure we could even publish, how it is, and then come back to it next year during Drexel AI and do some sort of hyperparameter search. This would be a good opportunity to talk about, like we did hyperparameter traversal algorithms earlier in the year. This would be a good way to practice, implementing grid search from scratch on a model without necessarily knowing what's going on with the model in the background. I don't know, but it is week 10 and I'd like to finish up a project because we've been working on it this entire term. So I'll do what I can, the remainder of this week to brush it up. But then I'll probably post the archive over the weekend before finals, and then I can send out the link and give you guys all updates about what I think we're going to do in the future. And then, we should probably talk about projects next term. And you guys have kind of, congratulations for making it, if you've been with us since fall, like congratulations making it like 4 terms, Drexel AI, whoop-de-doo. So I think the general scheme of, what we've been doing this past year is, in the fall term, like if you imagine this is, I hate yellow. If you imagine that this is fall and this is the year, right? This is fall. This is winter. This is spring. This is summer. Okay. I kind of want the projects we do to be a little bit more like reachable to new members in the fall, because like if you're graphing like difficulty or accessibility, let's do accessibility. Like how accessible it is to new people. I kind of want it to be low, right? And then I want it to be like gradually increase, right, to winter, gradually increase to spring. But then in the summer, I want people who are still sticking around to do something that's like exceptional. Like this project was a combination of three pretty popular techniques in machine learning. Right, you have to talk about evolutionary algorithms. You have to understand how those work. You have to understand time series forecasting, difficulties in that. And you have to understand sparse coding. So it wasn't trivial at all to get it going or to get everyone on the same page. But thinking in terms of the fall, is there anything you guys want to see as a project? I have some ideas that Asamu brought up to me, and then I've thought of.
Yeah,
Do you have any?
what were the ideas Samu said?
So Asamu, right? I think he brought up a idea that someone else brought up in a meeting. It's the idea that if you're in a Zoom class, right, you have faces on Zoom, and the professor doesn't necessarily know, actually, let's do this instead. So we're all on Zoom, right? And I think you can like give reactions, right? So I can go in and I can give the smile, right? I can give, what else can we give? Can we give some like mad emoji? Can we all be mad for a second? Like this, like, is there a confused emoji? Here, let's see. Or like this, yeah, like so someone's in the pig emoji. It'd be cool if that emoji could pop up just based off of our faces, right? So the idea is that you'd have to mine the expression in each of our cameras. So that deals with facial recognition. And I'm going to get away from the Zoom idea. And I'm just going to say, like, if you have like a face, right, you have a person, let's just say, let's be in creeps and looking at their entire body, right? You want to be able to find their face and then somehow identify what category they fit in. And those categories would correspond to emojis that you could like put in the upper left-hand corner, like this guy is happy. Those would be our labels, right? So I think that would be a pretty cool way to integrate machine learning into Zoom, because we'll to integrate machine learning into something that's useful, because, when we're on Zoom, if you could trigger something in the background so that emoji would pop up, or so that there'd be an artificial, have that option for developers. I don't think so, but there's things you could do. I'm pretty sure there's things you could do to like make that happen. There are like when you think about like Chrome, there are Python libraries that can manipulate Chrome called like Selenium. That's used for automation and testing, and people use it for creating like online bots. So I'm sure that we could figure something out similar for Zoom. Might be more difficult because it's like a web app, because it's a desktop application as opposed to a web application. But even getting the algorithm to take in a face, this would be the features. The features would just be the image, and then the label would be what we think of the emoji, like what would they have pressed given their face. So something fun would be, we would take pictures of all of us, right? And then we'd have like different, like smile, like mad, and we'd use that as data input. We take Drexel AI data of just us, and we'd use that to basically train a machine learning model on these emojis or these expressions. That would be something useful. And then the application could be, we want to interface this with Zoom. While facial recognition and tying that to like recognizing a face and tying it to expression isn't novel, what could be novel is the integration with a software as widely accepted as Zoom. that'd be novel. Because Zoom doesn't have it, right? And I don't know of any software like Zoom that does that, where they actively try to guess what, or actively try to predict what you're feeling based off of just your facial recognition, you know. Sorry. You know, and then what would be another indicator is if you have these like if you're a professor, you want to know what percentage of the class. So like, let's just imagine you are, oh, how do I delete all this? Let's say you are a professor. You might ask, okay, so throughout this lecture, what was like the average expression of a person, right? And you might get like these different categories. You might get these different categories, right? You might get like happy. You might get sad, right? And you might say like, oh, during class, 50% of the class, 50% of the time people were unhappy, but the other half of the class, 50% of the time they were happy, right? You could even get like a pie chart that represents like, oh, this is like happy, sad. But this gets into like displaying the data. But once we have the data, it's really easy to show it in different forms that'd be useful for people to interpret. But I think that would be a fun project to start off with in fall term. I know that I don't have experience with facial recognition or those kind of algorithms. That's more computer vision-y. I'd like to learn. So I think that might be a good project that we could explore together.
One idea that I had, if like we could still use computer vision, like Drexel Medicine, and they collaborated with the Tower Medicine this like last month. So I reached out to a few professors, and I don't remember the name of the professor, but he's working in breast cancer imaging, right? So
Yeah.
maybe we could collaborate with them, take some data, and uh, do a basic tissue kind of like recognition software with CNN, which is like almost the same thing.
Yeah, we'd have to see what they're doing, because it's good practice to not to replicate work, to reproduce published work, but like we want to do something that is new. People can
So how about also that, what if like in this project that we did on our evolutionary multivariate sparse coding project, what if we name this as like one algorithm, we get it to publication, and then use this algorithm to say some sort of data set, and that would be our second project.
Yeah, it could be. I want to make sure that when we do another, I don't know, because I like starting new projects, because then we don't get stuck on a problem. It's really easy to get stuck on a problem and just work on it for a long period of time, and I don't like when that happens. And as a club, I kind of want to keep interest going, new ideas. People get like a breadth of information. It's not really my job to give people a depth of information. My goal is more likely to give people a breadth of information, like, because when you're an engineer, you don't need to know a lot about details. You'd be surprised about how little I actually know, but you just need to know a lot of different things. That's what makes a good engineer. And then as long as he or she understands like at different levels of scope how they fit together, that's fine. I'm serious. It's crazy. Alicia.
Oh, yes. Hello.
Yeah. Yes. Just, yeah. Cool. But yeah, these are all ideas, and I could even send out another survey asking what people would want. And usually the first meeting in the fall term is, reserved for idea development and brainstorming.
Yeah.
And it's pretty exciting too.
Are we meeting on campus or is it on Zoom?
I don't know yet. I don't know. It's more convenient to have it over Zoom.
Because I'm coming on campus on 2nd.
Yeah. We'll probably do, because I like because like man, if we were in person, it'd be really hard for me to draw on my screen. Just saying. I could do it. I could get a marker and just like draw. I'm joking.
Yeah.
But we might do like project meetings on Zoom, and then if we have events, like maybe like 3 or 4 events throughout the year, maybe every 2 weeks, we get together, get some pizza, do like some reading session
Oh,
or papers journal club,
Yeah.
Yeah.
kind of
Oh,
what Professor Kim does, Alicia, but we do it like together in some
Yeah, I think
building.
I think he did that last year, I think.
Yeah.
Yeah.
Who,
Yeah, I
Yit
saw-
or Professor Kim?
I think Yit did it. I remember because I got the readings, like what they were presented. I just never like actually went in person because I never got access to like enter CCI like that.
Oh, is it CCI?
It used last year it was at CCI.
Well, how would I get a CCI?
I think you have to like be taking a CS class, I think.
Well, I'm actually taking a term off, so I don't know how any of this is gonna work.
I mean, you can probably ask them like how to do
Yeah,
it.
I'll ask Professor Kim, yo, I need
Yeah.
a favor.
Yeah.
Cool. Yeah, so that's it for the paper. That's it for the term. If you guys want to add anything before this weekend, I'll be working on it tomorrow for a good period of time. I'll be working on it. I'm trying to get it out on our archive by Sunday. That'll be my goal. Yeah. I like the story it tells. I mean, it's a different idea. I'll probably read through it multiple times just because I'm crazy. Usually anything with my name on it, I'm very careful about, what I put together because I want it to be good.
Yeah.
Cool.
I have
Yeah.
a question.
Okay.
So, when a paper is archived, does it still mean it's being published, or is it just like archived for later?
Okay.
Yeah, it's a
Archive
preprint.
is a Cornell is a database hosted by Cornell. So if I log in to archive, the archive is a unpeer reviewed way of publishing papers. So when people say, "Oh, I'm going to publish this paper," it's not like every publication they give out will be peer reviewed. Like for instance, I have 3 on archive. I don't have all mine on archive. I don't know why, but I can look at like what we did last time. This was not peer reviewed, but you can still access it. And then people can go onto Scholar, right? And then they can find it that way.
It's essentially that because like the whole peer review takes a lot of time, so that
Yeah. Oh
your
my God.
idea doesn't go like not nowhere. So it's like at least published, and you could get citations out of it.
Yeah.
then,
So I can go to this one and I can see, oh, it's on archive. It's a preprint. They're usually called preprints. And it'll take me to exactly this. And I can just go to PDF or other formats or whatever. So that's I didn't know what it meant either, but that's what it means. And then the easiest way to get a paper like peer reviewed is through a conference. If you don't do it through a conference, the easier way or the more difficult way is through a journal. We haven't put in, we put 2 conferences through, we put 2 papers through conferences this past term, I think. Yeah, 2 of them. Yeah, this will be our 6th paper this year. 2 of them were peer reviewed through a conference or whatever. Yeah.
But
Oh,
I think
also,
there-
yes,
Go ahead.
I was gonna change topic, but you can go.
I was saying like there are like few not so good journals, like
Yeah,
they're still good, but we could like they're in Scopus and everything. So maybe we could try for them. Like
yeah.
in the meanwhile, they will be in the publishing. It won't be like hurting us anyway. So
Yeah, good point. We have a table for what's it called? Welcome week for the club fair. So what I'm gonna do is I'm going to print out the papers we did this year, sit there with my laptop, maybe come up with some cool way to display some of the projects we've done. We don't really have anything too visually interesting. I can talk about, I could show the proteins I did, like the 3D structures. I could pull up like 3D structures of proteins, be like, yo, we worked on this. I could kind of make it sound a little bit cooler than it actually was. There's this software called PyMol, which allows you to look at protein structures in like 3D. So that's pretty cool. Be like, yeah, we worked on the protein prediction problem, the protein folding problem. We worked on time series forecasting. We looked at like neural networks. We work with neural networks all the time. We worked on like optimization of neural networks, stuff like that. And then I don't think we have a sign.
Don't have a sign.
No, I might put something together over the next 2 weeks. Go to Home Depot and build something. I don't know, just a giant sign that says Drexel AI. I'm not too crafty, gonna be honest. I'm very much not so. But yeah, cool. This was fun. Fun year for everyone who's been participating. Fun term for everyone who's been on this term. I really hope that you guys learned something. I know I may have forced you guys to learn something because I've tried to delegate things more because it's often difficult to kind of do the project like all by yourself, and I don't like want to run it like that. I mean, I think I'm more of an idea guy than someone who actually like does stuff. Usually you want to be the idea guy because it means it all depends like where your strengths are. But for me, being the idea guy is fun. But you guys have been great with helping out and researching and all that. So I appreciate the time that you've taken with the club. And we don't have yet anymore. So now it's my problem. Now I have to figure out what the hell I'm doing. Yeah, if you guys have any suggestions about like things to do next year or like things to change or projects or whatever, let me know. I want to make it as reachable to people as reachable to as many people as possible so that they don't get like lost in the details. And that's why I try to make like Ansh, that's why I try to make the code as reproducible as possible. I spent a lot of time on that so people could like download the same data set, have it segmented the same way, be able to run the algorithm themselves if they really wanted to. Yeah. But yeah, that's my 2 cents. I don't have much else. I kind of just want to go to the gym. So do we have anything else going on?
I had a quick question, but
Sure.
it's like not related to Drexel. It's about like Chop, like with
Yes.
the Happy project. Do I need like a Chop email or like anything or like the GitHub? Like I'm not part of that, so I can't really see anything.
Oh, you aren't?
Yeah.
Oh goodness. Send me your GitHub.
Yeah.
Zavek, Alicia is a part of my lab at the Children's Hospital. That's why. That's the relation.
Okay, right. She's like part of like so many labs.
I know. You got to calm down, Alicia.
Yeah.
There would be a time like Alicia has every single lab.
I wonder if I can share it with you. I might not be able to.
Yeah, I put in the chat my GitHub.
Yeah, I saw. I'm gonna message Wanding. If you're ever like not added on anything, just ask Wanding. He's like really chill.
Yeah, like I met with Shums and Elaine and they sent me
Yeah.
the onboarding link or something because like I didn't know there was any like onboarding stuff.
Yeah.
So
Yeah.
Ethan, do you know like if Professor Kim works with medical imaging and sparse coding, because it said on his webpage that he does.
Yeah, so he got this huge grant from DARPA to do sparse coding with ultrasound.
Oh, yeah.
Yeah, so I would reach out to him if you're interested. He likes people who are motivated, who want to learn.
Like, because I'm like literally looking out for people who are doing medical imaging and AI stuff.
Yeah. It's cool.
Their hobby.
You know, Professor Kim he's chill.
Yeah.
I'd reach out. Just be like, yeah, you know Ethan or you know Alicia or something like that. So
Yeah.
Ethan and Alicia told me to come talk to you. It's that easy. Cool.
Sure, I'll on an email.
Yeah, so Alicia, you had a meeting with, so did you see the code or did you?
No, we couldn't really do much because I didn't have access to anything.
Oh. You have the Dropbox though, right?
Yeah, I have the Dropbox you sent me on Saturday.
Yeah,
But yeah, I mean,
I think so.
we're gonna meet again on Thursday or Friday to
Yeah.
like actually like do stuff once I like get everything
Yeah, cool.
access and stuff.
Yeah. Yeah, I think that's all then for like the club. Yeah, we'll be back in 3 weeks, probably. Yeah, I think so. 3 or 4 weeks, probably not welcome week, probably week 1. So 4 weeks, plan on a month from now.
Are you gonna meet any club members for the table?
I mean, yeah, I mean, you wanna stroll on by, come on, sure. Like I'll keep you guys updated on I'll keep you updated on Slack. I don't want to be the only one there. It'd be cool to have other people. It'd be kind of lame if we have all these members. It's just me. Yeah, but it'd be cool. I want it to be fun. I want people to think like, oh, like AI, like that's cool, not like, oh, AI geeks, I want to give off that kind of vibe. So I want to be like, yeah, professional and stuff. Yeah.
Like show them good graphics, like put some neural
I
networks.
know I'm working on that. I have to come up with something to show.
They need I have some cool graphics, but they're all like brain MRI and stuff. But they're
That
really
is okay. That is okay. That is more than okay.
Sure.
Send them my way.
Sure,
I might even highlight some of the posters we've done.
Yeah.
We've really done 2 posters. The papers, I'll have them printed out so people can like check it out.
We can talk about the
Good.
research conference that we had recently.
Yeah. Exactly.
Yeah. Oh my God. Yeah, I forgot about that. We held a research conference.
You could show the
Um,
posters of the research conference.
Yeah, I can print out those flyers. Have those as like decorations that
Yeah.
we sent around.
Also,
Cool.
what's up with the proceeding of the conference?
Dude, that just isn't going to happen. I looked into like IEEE and like you have to like talk to them beforehand, like before the conference happens. But I do have all the papers, so I can like I can stitch them together in the next
And
like
just put it.
and just like put it and archive it or something. I don't know if you could do that because it's like I don't know if you could do that, but
I don't know.
maybe I can. Maybe if we like get a title page or something.
Or we can use those posters that like people submitted and like show it at the involvement fair too, I guess.
Yeah, that's what it's called. Yeah, I have to. So like, just keep reminding me about the just bug me. Okay, bug me tomorrow. Remind me tomorrow. Writing myself a note. I'm doing that tomorrow. I need a sticky note. Drexel AI. Proceedings on archive. I'll do that tomorrow, like first thing tomorrow morning. I'll like because I have them all from everybody.
It's just that we need to put it all together and
Yeah, and then like so it shows up on Google Scholar.
yeah.
Cool. Yeah, how are classes going for people in classes?
It's going fine. I mean, finals are next week, so.
Yeah. Alicia, what classes do you have?
I'm taking CS 270, EC 204.
What's 270?
That's the mathematics of computer science, the one with racket, like recursive programming.
I'm not in CS. I'm just curious.
Oh, okay, that's what it is. I'm taking discrete math.
Oh, I like discrete math.
What else?
Discrete math is very fun.
Yeah.
We should probably do a project on graph kernels. Those are pretty cool.
Graph what?
Graph kernels. It's like
graph coloring?
Kernels, like
Kernels.
kernels. Yeah.
Oh, I've never used that before.
It's really cool. It's for like basically I use this for one of our projects in Georgetown. So
Mhm.
it's basically you take up, wait, I can show that actually. It's really cool. One
There's so
second.
many gnats in my room. Yeah, if you want to lead a project, like by all means, go for it. There are so many bugs in my room. Oh my goodness, all the gnats. I hate them. Are gnats like baby flies or are they completely different?
I have no idea.
Ah,
But they are annoying. I can
Yeah.
definitely agree with that.
yeah. It's funny too because I post all of these on YouTube, right? And no, like that's not the funny part, but like I'm gaining subscribers. Like I have 8 subscribers now, and I don't know where they're coming from.
Oh, nice.
Um,
When you make revenue, you gotta split it with the club, you know?
I really don't think I'll make revenue. I that will probably never happen at this rate.
Can you see the screen? Right?
Yeah.
Okay, so it's basically they have taken the Taiwan data set, the NHRD data set, so it's like 1 million people,
Mhm.
and their health records for like 10 years, and you take a disease type, and then you have all of, like, you choose a patient, and you have all of their disease, prescription, what they have taken and everything. So we have created a dashboard that you say they are being diagnosed with these diseases, and then these prescriptions were given. So what are their chances of like surviving? Like, how is that drug prescription gonna impact that particular individual? So it gives out like a success rate,
Yeah.
how that particular drug is, helping. So these are like nodes.
Yes.
Um,
I see. I see.
Yeah, it could be a really cool thing if we are working with
Did you
tabular
make
data.
did you make this dashboard? What'd you use?
Oh no, I didn't work with the dashboard. I
Oh.
worked with the whole AI thing and
Like
the data
this.
set cleaning. Yeah.
That. Okay. Who made the dashboard?
Oh, this is a guy from Georgetown. He's a PhD student. His
Okay.
name is Hao Ren. He does all this stuff.
Do you have the project repository?
Well, I do have it. I don't think I could share that.
You can't share the front end.
No,
Mm.
but they're still working on it. So, like, they give an offer letter of a 1 page and the non-disclosure agreement of 8 pages.
I
Oh.
see. I see.
Yeah, it's like pretty complicated.
Yeah. Cool, but thanks for sharing.
We could probably do something like this.
Yeah, I like that. Cool. We're done. Okay. Cool. I'll do all those things I told you I do tomorrow. And then I'll give updates.
Sure.
Yep. Appreciate you guys sticking around.
Cool. See ya.
See you in 4 weeks.
Yeah.
Goodbye.
Bye-bye.
So, yeah.